And we're live.
Yeah, we are live. So, hi everyone, and thanks for making it to another session of our Terramate Office Hours. And yeah, this time it's already volume 6 of our series. And I guess that some of you might have also joined our webinar past Wednesday, where we have been talking about Terraform automation and collaboration with GitHub Action, which has also been a really nice and active session. So, yeah, also thanks for participating on that one. But today it's, of course, Office Hours Wednesday. And yeah, today we will be talking about stacks and how to manage environments with Terramate. But before I will be talking the whole hour, let's say hi to Sören, who is, yeah, some kind of next to me. Hi, Sören. How is it going?
Some kind of next to you, just
Yeah.
separated by a few hundred miles. Yeah, good. How about you?
Yeah, also great. Thanks.
Doing well. Interesting times here with potential HashiCorp acquisition by IBM all over the community. People freaking out, panicking. Um, yeah, it's interesting to see. Yeah, but other than that, I would say it's all good. OpenTofu just issued a major new release. And they now support Lua functions through an external provider function, which is great. So that's quite refreshing to see. And yeah, so thanks everybody for joining. Great to have all of you here. Today, I think we wanted to, so we repeatedly get questions by the community how stacks in Terramate actually work and what's the purpose of a stack, how to structure stacks. And and those kind of things. So I'm going to take some time to walk you through some more actionable examples, and then we'll have time um, for Q&A too. Now, um, right. So let me actually share my screen here.
Yeah, the
And
Q&A, like usual, at the end of the session. But I will, of course, have a look at all your comments and questions. And we will also make sure to answer those at the end.
let's do it. Um, awesome. So quickly sharing my screen here. So this is the Terramate docs that we see at terramate.io docs, and there's comprehensive documentation about what stacks actually are. So so why stacks? I would say is the first question. So to understand that, let's look a little bit at how Terraform works in a more fundamental sense, right? In Terraform, typically you have one or multiple root modules um, that manage state, right? And the state contains sort of the last representation of your latest deployment of all resource managed inside this module. So that means that the more resources you add here, the longer the CI/CD runtimes, the higher the potential, the bigger the potential blast radius, etc. So now stacks help us to split this up into kind of isolated units that we can execute in an isolated manner and in parallel. But at the lowest level, stack and Terramate is basically just a directory with a stack.tm.html file inside. So let's break this down and look into this basically from a fundamental point of view. So I can create a new stack with the Terramate create command by just saying, okay, create a stack A. And hopefully this works. Yeah, it does. So, so what this does is it basically creates this directory for me. And then we have this language server crashed in the backend for whatever reason. And then we have the stack.tm.html, which includes the stack block where we can configure name, description, and ID of a stack. And all of those parameters here, all of those attributes are configurable via the CLI too. So if I was to if I create another stack, for example, create stack B, I can just say, okay, give this a name, some stack, and a description too. description. Some awesome description. All right, so now what we can see here is stack B basically has an updated, has a new configuration file inside. It's called some stack, and then the description is whatever we passed here as arguments in the CLI. So that's cool, but that doesn't really relate to Terraform, right? So it's basically just two directories, two configurations. The reason for that is that Terramate requires a stack block instead of a directory to actually identify something as a stack, right? So if we now run Terramate list, the CLI basically gives us a list of all stacks available in our project, right? All right, cool. So let's remove all of this and start from scratch. I'm just gonna make quickly sure that we are on the latest version here, by the way, because I think it's not installed ASDF. So ASDF is a nice package manager that we use here to manage multiple versions of the same tool locally. It's really great. If you don't know, check it out. So I use it for everything, for Terramate, for Terraform, for TerraGrunt, for everything that starts with T. So now Terramate version. Okay, so and then we say SDF local Terramate latest. And now we should have version 0.64 here. Awesome. So let's restart VS Code to make sure that the language server works. Okay, I think now it looks good. Okay, so to understand how this works with Terraform OpenTofu, I don't know, do I have Tofu installed? Yeah, let's use Tofu for this session. We can basically create a new stack. Terramate, create, let's say S3 bucket. Give this a name. Call this S3 bucket. We'll also see later on what name and description are useful here. This is an awesome S3 bucket created during the Terramate Office Hours. Yay. Shoot. Okay, cool. So empty directory. Now what we can do here is we can basically just create a Terraform file and say, let's ask Copilot, provide the Terraform code without backend or provider configuration to deploy a private S3 bucket on AWS. Something like that. Right? Accept. Holy moly, that is a lot of code. We don't need encryption. And we also don't need that, I believe. Let's see. Actually, let me look at the docs quick, how this thing is configured. Haven't done that in some while. Terraform. Let's look at this because I think it's ACL defaults to private. Awesome. Okay. So we call this bucket Terramate Office Hours. I don't know, private bucket, something like that. Okay, so there's no backend and there's no provider definition in here, but it's cool. We don't necessarily need that. Yeah. So what next? With one stack, yeah, and of course we can execute commands in stacks. So what I can say is like, hey, termate run, and then I could say something like, hey, echo hello world, right? So that basically just runs the command echo hello world inside the stack, right? I of course could also say terramate terramate run terraform init. So now what this does is terramate run basically does a similar thing than Terramate list. So it kind of gets a list of all stacks managed in our repository. Repository equals Terramate project, um, and then we can just we can just use this list to iterate on and to execute commands and lists in stacks, right? But right now we only have one stack. So, and what this does is basically it runs Terraform init, meaning it just installs all the dependencies like modules, providers, and sets up the backend that in our case is local. So now let me use AWS Vault here um, to make sure that I have a working AWS environment. Oh man, what was my secret here? Okay, this should work. Awesome. And now in theory, if I run Terramate run Terraform plan, so this should execute Terraform plan inside a stack. Let's see if that works. So that works. It gives me a plan here. And basically says, okay, this creates and deploys a Terraform S3 bucket for me. Cool. So now the next thing that I want to do is I just want to create a similar stack just for another bucket. So what I can do here, either I just create a new stack or by saying or by cloning the existing stack. And I could do this with Terramate experimental. So this is in experimental because we're still working on this, but it's been working well for some time. So we might as well just move this to the stable namespace. Taking a quick glimpse here over to the product owner soon. So we call this another S3 bucket. So what that does, it basically looks at the stack S3 bucket, right? And then it clones it to a new directory. Well, that could also be just a simple copy command. In fact, what happens here is that if we look at the ID of the S3 bucket stack, 8FD, so it generates a new ID upon cloning. And then also, if stacks are nested, we can, of course, clone deeply nested stacks. So let's update the naming here, though. Another S3 bucket. This is another awesome, something like that, S3 bucket. So now, if you run the list command here, what you can see is that, okay, this Terramate project contains two stacks. And to execute Terraform init sequentially in both stacks, you can basically say, hey, Terramate run Terraform init. And now what you can see is, okay, it enters. So it basically enters the another S3 bucket first. And the reason for that is before it enters the S3 bucket stack, and the reason for that is that Terramate orchestration uses a similar order of execution to how the Linux directory tree file system is sorted, so alphabetically in this sense. I can also do this in parallel, right? So I can just say like, hey, right now we execute one stack after another sequentially. So now both of those stacks are independent to each other. There's no dependencies. So and Terramate will detect dependencies and then change to sequential execution. But essentially I can say, okay, so now execute this command in parallel using 5 threads, right? So what this is saying, literally translated, is like, hey, so Terramate run the command Terraform init in all stacks and do this in parallel using 5 threads. So I do this, and now what we can see is, okay, so both the output's just random now, of course, which is a problem that we solve with Terramate Cloud, right? So if you want to rely on parallel execution for drift detection or whatnot, this output will become unreadable in the terminal. But then if you pipe this to Terramate Cloud gives you a nice representation of like, oh, this is all my stacks managed and whether there's drift or not, right? In a super efficient way. So this is like faster than running on any purpose-built CI/CD, a native Terraform, whatnot. Extremely fast. But then also depends on how you structure your stacks, of course. Awesome. So now for us to understand the concept of stacks a little bit further, so far, what we've done here is, so basically we created two stacks and then we put a bunch of Terraform inside, right? And what you can see here is if we were to deploy this right now, both buckets have the same name here. That would not work because bucket names in AWS are unique in the global AWS namespace. So if you decide on the ID for bucket and this has been taken by another organization, then will only recognize that at apply time. So we want to kind of make sure that this name here is unique, right? So what I'm going to do here is I'll move this to a code generation template. So for that, I can basically say, okay, mixins, something like that. I'm just going to create a new directory here. And then I call this s3 bucket.tm.htcl. So Terramate configuration file. Now what I can say is I can say, hey, okay, so in here, I use a statement generate HTML. And what I'm saying here is like, hey, okay, so this configuration should generate an HTML file called s3 with, and we give this some content. Let's put this in here. Okay, run Terramate format. Okay, with the format command, we can basically format any Terramate configuration similarly to what you used to from in Terraform, right? With Terraform FNT, you can, and with the recursive flag, also format any Terraform configuration. Terramate does this per default recursively, so we just got rid of doing this on one specific file. Doesn't really make so much sense. Okay, so for us to now understand how this works, right? We have this mixing here, and you can see that I'm just gonna delete the Terraform files from my buckets here. So from my stacks here. So it's empty stacks again. Yeah. And honestly, let me also just remove all this Terraform dependencies here. So we have a little bit of a cleaner view. This is just a downloaded provider. We don't need that now. Okay. All right. There we go. Okay. So again, two stacks, nothing inside. If I want to use this code generation configuration that I just came up with here, what I can do is there's multiple ways of doing that, right? I can import them at the top of the project by saying something like, okay, imports.tm.htcl. So now this is called imports, import, and then we give it a source. We just say import this from mixins, and then s3 bucket.tm.htcl. And of course, we can also just say, okay, glob import, something like this will work. So now what this does is we can run first the Terramate format and then the Terramate generate command here. And what you can see is, oh, I basically have an error in my configuration. That's interesting because you can see I just created a file called s3 without any suffix. So let's change this. This file should of course be called s3.tf or maybe just main.tf. And we regenerate the code generation. Now you can see it deletes the old files and it generates those main.tf files in here. Yeah. So now those are generated inside two stacks. But they still have the same name. So one way of basically doing this, multiple ways of having dynamic names. So I can just go in here and I can say something like, okay, so instead of hard coding this, what I want to have. I want to basically say Terramate stack. Um, Let me see. Um, Pass base name, I think it is. Let me quickly look this up in the docs. Um, Metadata. Metadata. Oops. Project metadata. Here we go. Um, Pass Terramate stack. Pass base name. This is it. Terramate stack. Pass base name. Okay, I wasn't too wrong. Um, so now instead of hard coding this, um, upon each creation, upon each code generation, because the way the code generation works is basically it detects every single stack, and then it decides whether or not we should generate code inside. And I will also look into how to conditionally enable this or not. And now it will basically say like, hey, the name or the value of this attribute bucket here should be the name of the stack. So if I run generate again, you can see it updates both files here. So it says, oh, code generation success. Another S3 bucket and S3 bucket both have been updated. So now if we look at the main.tfs here, we can see the attribute bucket equals the name of the stack, the directory name of the stack. Same here. This must be another S3 bucket. Cool. So this is one way of doing it. Another way is to, of course, say, okay, let's make this configurable. So what we can say is in Terramate, we basically have Terraform functions available. They are prefixed with tm underscore here so that you can still use and render Terraform functions without evaluating those. So what I can say here is, you know what? Let's look at this concept global S3 of global bucket name. And now what we'll do here is we say, okay, if there's a global variable available in the bucket namespace called name, use this. Otherwise, fall back and fill this, assign the value to assign the bucket name value to the name of the actual stack. Okay. So if we generate this again, nothing should happen. Exactly. Why? Because we don't have this globals available in any stack. Hence, it just falls back to this. And by the way, we can, to be careful, already do this here too. So we say global bucket ACL. And if this is not provided as a global variable, then we just fall back to private. All right. So if you go into the stack here, S3, and just adding a configuration file in here, terramate.tm.htl. And by the way, this may be a little bit misleading, but like tm.htl files on the same directory level will be merged into a single file at compile time. So it doesn't really matter at runtime. It doesn't really matter how many files you have in here and how you name them. You could, in theory, also just put everything in the stack.tm.htl, but personally, I prefer doing it this way. So we can define globals with the globals block. So now, if we want to create a namespace here, bucket, we can do it like this. And you can see that apparently Copilot gives me some nice suggestions here. So what you can see is like now we set this global variable bucket and we assign a few attributes here. So name and ACL. Let's set this to foobar and run Terramate generate, see what happens here. And you can see that only in this specific bucket, in the stack S3 bucket, we have the updated code generation now. It's not in here because here we don't set anything. So this just falls back to the base name of the stack. Whereas So for example, I can also set this to public here, just run regenerate. And now it has ACL equals public, right? So it's pretty straightforward. And just quickly look at this here. So this is one way how we can define globals. But then, of course, we can also say, okay, another way of doing this is by saying I add the namespace up here. And now this is a direct assignment. So now this says, hey, globals in the bucket namespace, add the following attributes here. So if I run generate again, nothing should happen. Still, the code here is exactly the way we expect it to be. So why is this nice? The one thing with globals here, and by the way, this is like really well documented. So if you look at the code generation docs, you can see that the way that we call this in Terramate is code generation strategy. So you can use code generation to generate a bunch of HCL typed. So and evaluate it in the IDE. So whatever you use here, like globals, for example, if I was to remove something here, like just in type, you can see the IDE feedbacks me. And that's because there's a language server running in the background. Whenever you install Terramate, it installs the Terramate CLI as a binary, but then also the language server. So it really is a great experience writing Terramate configuration. See it as a superset on top of Terraform. I'd say the comparison here is maybe a little bit far-fetched, but JavaScript and TypeScript, at least we share similar goals here. And then the language server can easily be integrated with VS Code, right? It's just a plugin that you can install and does everything for you. So let's run this once again. All good. Okay, let's go back to stacks. We just photos for now. And we already learned that with Termate list, we get a list of our stacks, right? And then in order to run a command, we can just run terraform init here. So let's do that. So this runs terraform init in parallel again in all stacks. And again, what's great here is that we always produce native Terraform code with the code generation. So apparently, I could also just cd inside of a stack. So what I could do is I could say cd change directory 3 bucket, and then I just run Terraform plan in there without Terramate, right? And because it's a native, oh, deprecation error. Well, wrong configuration. Let's just run the init command for now. But to demonstrate it, this is a native Terraform environment. So we can just use code produced by the code generation and run it and integrate with all third-party tooling, right? So that works with Checkov, that works with TFSAC, TFLint, and infracost and whatnot. And there's no integration that need to be written in order to integrate with Terramate here, which is pretty nice. So there's other tooling in the market was like, oh, do you guys integrate with infracost and whatnot? And it's like, nah, probably not. So the way that we think about it is a Terramate is like, hey, outcome, always native HCL, and we want to be able to integrate with all tooling in the market. Okay. So now let's look at a little bit more of the stack ordering here. And then we can look at how to manage environments with stack. So Terramate list, sorry, I'm in the wrong directory. Terramate list gives me an overview here. Yeah. Now we already know that we can nest stack. So what I can do is I can say, let's just create, let me actually just create another stack. Terramate create, I don't know, S3 bucket, and I create a stack nested. So now if I run Terramate list here, you can see it goes through those 3 stacks. And what I want to do next is I'll basically just, let me think about this. Terramate create, another 3 bucket. We also call this one nested. Terramate list. Okay, so now if we want to figure out how things would execute actually using the order of orchestration, we can say something like run order here. The nice thing is the run order here is similar now, because we follow the ordering of the Linux file system. We say terminate run, echo, pvd, I don't know, something like that. You can see, okay, it executes another S3 bucket first, then another S3 bucket nested stack, then the S3 bucket, then the S3 bucket nested stack. So sequentially. Now, if I do this in parallel, what will happen here is 10 threads or whatnot, and there's 3 threads. It doesn't really matter. What will happen here is that, okay, so Terramate will detect that another S3 bucket and nested are 2 stacks that relate to each other, that are dependent on each other. So it will always execute another S3 bucket first before it can eventually execute the nested bucket. And the same as S3 bucket, right? So it does this stack first and then the nested stack first. Meaning another S3 bucket and S3 bucket, what terrible naming, can be executed in parallel, right? But the nested stacks cannot. Only once the parental stacks have been executed, Terminate will eventually move to the next level of orchestration. Let's do this. Oh, that's in parallel. Okay. Okay, that was an error. So now you can see this exactly what happens here. So it executes in parallel the stacks on this level, and then it apparently just runs one of these nested stacks, yeah, sort of in parallel, not exactly at the same time, but there's like some race conditions, and if I execute this again, the output will be different. That's just the nature of parallelism. Okay, so now, how about environments? Let's remove this, all of this. Um, so environments in Termate are always or often one service per environment. Yeah. So the preferred scenario here is, let's say, Kadir stacks, just adding a new directory here, stacks, and then maybe stacks prod, stacks staging. So just 2 directories to separate, could be accounts in AWS or whatnot, right? So now if I to create a VPC, I would basically say Terramate create stacks staging VPC. Yeah, let's do this. So we have a VPC stack in here. Let's look for an so Terraform module AWS VPC. I know Anton has one here. This one. Let's just use this module for now. Copy paste. Awesome. So we're just gonna add a main.tf here. Let's see. And so it's just called my VPC for now. And then we have the availability zones here, the private and public subnets, NAT gateways. We probably just don't need that right now. Same here. And then environment. It already becomes clear that we want to have this configurable, right? So I could, of course, like just use Terraform variables here, but I think I do myself um, I do myself a favor to move this to code generation. So what I'm gonna do here is um, I'll add um, I'll add a new directory mixins. Um, then let's add a file in there vpc.tm.hcl. And we configure this, generate HCL main.tf or maybe vpc.tf. Content, model VPC, format, good. And then we just use globals here. So we say, hey, global VPC name. And here we say global VPC CIDR for now. Let's just leave this for us just to demo purposes. And also what we want to say is like, whenever you use this code generation, set this, don't inherit this. So code generation in Terramate is per default is like, hey, if you import code generation of any point of your directory tree, it's basically inherited throughout the whole hierarchy, meaning if you have nested stacks, then you also generate the code in there. With inherit false, it means it will only be generated at the level where you import. So that means if we go in here, let's just delete this, and then we basically in the stack.tm.html we can use in import statement and say source import this from mixins vpc.tm.html plus we configure this in here. So awesome. Already globals see. Oh, here we go. The GitHub Copilot was actually not good. So we call this staging VPC, and then the CIDR block. We just use what we have here already. Was that 10? I think something. This is 10. So 10 0 0 0 16. Was it that? Doesn't matter. So now what this does is this will basically import this module, this code generation module, and generate the code in here. Let's try this out. Terramate format, Terramate generate. Yeah, that works. Awesome. So you can see we have this VPC module in here, right? And now if we were to promote this to another environment, so what you can do is you can just say like, okay, so Terramate experimental clone stacks staging VPC to stacks production VPC. And now this basically clones the stack. This also regenerates the code generation, retriggers the code generation. So now, of course, we haven't updated the configuration here, but what we can say is we can just say like, okay, call this production VPC, and maybe use a different CIDR range here. So if I run the generate command, now we have two stacks here, right? Two VPCs. So what I'm saying is the preferred model with stacks is use different stacks for different services in different environments. Stacks come with support for workspaces too, but it's not as intuitive and easy to manage by just looking at the directory tree compared to just using the file tree and separating by actual stacks. There's multi-deployment support now coming, or multi-layer support. I think we call this for Terramate Cloud. So if you really want to use workspaces or any other way of configuring stacks by injecting different variables or so, this is possible too. So we don't restrict you in that sense, but I guess the best practice here is always to just map onto the directory tree, just similar to what you guys know from Terragrant, for example. I think they do it similar. And yeah, if I look at the community, I think like 50% of the community is doing it this way, and then another 50% of the community is using different ways like workspace and whatnot. Awesome. So hope that I could give you a little bit of an idea about very hacky, very hands-on session about how stacks work. And do we have any questions, Selina?
Up for now, nothing to add from my side, but let's wait a few seconds.
Let me just check here on all the other channels.
Yeah,
Nothing. Okay. So,
nothing.
oh yeah, there's actually one here. Let me look into this. So, do stacks always are stacks infrastructure as code agnostic? Can stack yes. So a stack in a sense, it's not necessarily related to Terraform. So in Terraform, cloud is also this concept of stacks, which is coming now, which is a little bit different than how we look at it in Terramate, but essentially with Terramate you can manage Terraform to for whatever you want. So we don't restrict you in that sense. Yeah, hope that makes sense. And I guess that was also the only questions
Yeah,
of
that's
the
it.
day. Awesome. Well
But a good
then,
one.
that was a quick office hour, 40 minutes. Thank you so much, guys, for tuning in, and Selena for guiding us
Thank
through
you.
until
Of
in
course.
14 days.
That's it.